And now we are going to discuss our assignment question, which is question 6-46. The question asks us to determine the force in members CD and CM of the Baltimore Bridge Truss and state if the members are in tension or compression. Also, indicate all zero force members. This is the diagram given by the question, and based on this diagram, we can know that there are 8 parts from point A to point I, which is from each of the part, the distance between the parts is 2 meters. Then, at point A, we can resolve into 2 components, which is component AX and component AY. Firstly, we need to find the moment at point I. Before that, we know that the equation for moment is perpendicular force times by the distance along x-axis. So, at point I, the summation of moment at point I is positive in counterclockwise direction, and the summation of moment at point I is equals to 0. So based on the equation of moment, force times distance, we can get that from point A to point I, negative AY times by 16, because the moment is in counterclockwise direction and AY is upward force, which is the direction will be in clockwise direction, and therefore AY will be negative AY. So negative AY times by the distance, there's 8 parts, multiplied by 2, so negative AY times by 16 plus 2 times by 12 plus 5 multiplied by 8 and plus 2 multiplied by 4 plus 3 multiplied by 6 equals to 0. Then, by multiplying all these numbers, we can get negative 16 AY plus 24 plus 40 plus 8 plus 18 equals to 0. Then, by adding up all these numbers, we get negative 16 AY plus 90 equals to 0. Then, by shifting this positive 90 to the opposite side, we get negative 16 AY equals to negative 90. And by shifting this negative 16 to the opposite side, we get AY equals to negative 19 divided by negative 16. So, the answer for AY is 5.625 kilonewton in upward direction. Okay, next, we'll discuss about the summation of Fx equals to 0 and Ax equals to 0, which is in equilibrium state. By referring to our question, we need to find the force in members CD and CM. Okay, first we need to draw out the free body diagram of these two forces. Before we draw free body diagram, we need to decide how to cut the truss. First, we need to determine the forces, which is in this question. We need to determine force CD and CM. Okay. Firstly, we need to find the summation of moment at point A. Okay. Why we choose point A? This is because point A is the nearest to the cut section of this force. So, we assume that the summation of moment at point A is in positive counterclockwise direction, and the summation of moment at point A is equals to 0. So, the calculation will be negative 2 times by 4. Negative 2 is because the direction of the force is downwards and it is in clockwise direction, whereas our moment is in counterclockwise direction. Therefore, it will be negative 2. multiplied by the horizontal distance from C to A, which is 4, and then plus the force Cm multiplies by the distance from C to A, which is 4. Then we can calculate out by transferring FCm multiplied by 4 to the other side and become negative 4 FCm equals to negative 8. And by shifting negative 4 to the other side, we can get FCm equals to 2 kilonewton. And FCm is tension because 2 kilonewton is positive. Tension is positive. Then we need to find the summation of moment at point M. We assume that the summation of moment at point M is positive in counterclockwise direction, and this summation of moment at point M is equals to 0. Then the calculation will be 4, which is the vertical force, vertical distance, multiplied by the force CD minus by AY 5.625 multiplied by 4. Okay, then we bring 4 multiplied by FCD to the opposite side and become negative 4 FCD equals to negative 22.5. Negative 22.5 is the product of 5.625 multiplied by 4. Okay. Then we bring negative 4 to the other side by dividing negative 22.5 with negative 4. And lastly, we'll get the answer for FCD, which is 5.625 kilonewton, and it is tension because 5.625 is positive. Tension is positive.
Second question for the group assignment is 8-44. The rings A and C each weigh W and rest on the road, which has a coefficient of static friction of mu s. If the suspended ring at B has a weight of 2W, determine the largest distance D between A and C so that no motion occurs. Neglect the weight of the wire. The wire is moved and has a total length of L. Then the diagram given is like this. First, we need to draw out the free body diagram first from the diagram. Okay, because it is the road between A and C and B. So the free body diagram based on the diagram is like this. Okay, 2 tension because it is a road. Then the B, which is referred to the weight. The weight given is 2W. Okay. Then the weight is pointing downward, so we must draw it downward. 2W. Okay. After this, we can do the summation of Fx equal to 0 and summation of Fy equal to 0. This is because the force is in equilibrium. Okay. For the summation of Fx equal to 0, we can know that there are 2 tension force in x direction. So, T cos theta minus T cos theta equal to 0. Why I write it T cos theta minus T cos theta? This is because the first T cos theta is referred to here. If the opposite of the angle, it refers to the sine. If the adjacent, it refers to the cos. So in this, we can know that here in x direction is T cos theta minus T cos theta. so equal to 0. Because it is in equilibrium, so no force in summation of fx. Okay, in summation of fy equal to 0. Okay, first t sine theta plus t sine theta minus 2w equal to 0. Why I write t sine theta? This is because it is in y direction, so it is sine. In y direction, so it is sine. And it is in positive because it's pointing to the upward. Okay, so plus law. Okay, why I write minus 2w? Because the 2w in free body diagram is pointing downward. So is minus 2w equal to 0. Okay, then we get t sine theta plus t sine theta equal to 2t sine theta. Then this one we need to shift to behind, become 2w. Okay, then t equal to 2w divided by 2 sine theta. 2 and 2 is the same, so it can be cancel, and the final answer would be t equal to w divided by sine theta. I refer to the diagram. When the suspended weight in ring B is being pulled, the ring A and C will be meet up to each other at the center. Okay, because this question, they want us to determine the largest distance between the point A and C, so that in free body diagram, we can either choose at free body diagram at ring C or ring A to know the distance. Okay, first in our group, we assume that the free body diagram at ring C. For the static frictional force, we know that F equal to mu Sn. But in this, we know that it is at the ring C, right? So we can know that the frictional static force is Fc equal to mu Snc. So we can write it out, mu Snc minus, why I write W over sine theta? This is because in the first one we get T equal to W over sine theta. So we just substitute T equal to W over sine theta into this. So we can get minus W divided by sine theta. So this one, the behind one, cos theta, just write it cos theta, then equal to 0. Okay. Then mu s n c minus w divided by tangent theta equal to 0. Why I write tangent theta? This is because when cos divided by sine is referred to tangent theta. Okay, so we just write it tangent theta. Okay, but here we have many unknown, right? So we cannot solve it. But don't be afraid. Please move forward. Okay, for the summation of Fy, we assume that for the summation of Fy in upward direction is in positive. So summation of Fy equal to 0. Okay, NC. Why NC doesn't have negative? This is because NC is in upward direction. Same as this one as we assume. So we just write it N positive NC minus W. Why minus W? Because W is point to the downward, so it's minus W minus T sine theta equal to 0. The T sine theta is referred to here. The opposite of the angle is the sine, so it's T sine theta. Okay, so this one we just write it off. NC minus W minus T. Just now we can know that in the first equation, we can know that T equal to W sine theta. Okay, so here we just substitute it inside W divided by sine theta, and then the behind one sine theta, just continue to write sine theta equal to 0. When sine theta and sine theta, so we can straight away to cancel it. So leave it NC minus W and leave it minus W equal to 0. Okay, NC minus 2w equal to 0. So the final answer for NC is NC equal to 2w. This one we move it to the behind. So NC equal to 2w. Okay. We just leave it first. Then we substitute NC equal to 2w into equation 1. Okay. For the equation 1, we get this one, right? US mu S NC minus w divided by tangent theta equal to 0. So we just substitute NC is 2w inside and minus w over tangent theta equal to 0. Mu S 2w equal to w divided by tangent theta, because this one we already moved behind. So tangent theta we move to the front. We only switch we only switch the place between the tangent theta and the mu s 2w. So tangent theta equal to w divided by mu s 2w. When w and w it can be cancel. So tangent theta equal to 1 over 2 mu s. The question needs us to find the distance between the rings A and C. So firstly, we can draw this triangle out, okay, by this. Okay, the total distance here is unknown, so we just write it D. Okay, first, for the distance for this part is we can divide by 2 because got 2 part. So this part is d divided by 2, and then for the other part also same, d divided by 2. And then from the question we only know the total length equal to L, but here got 2 length, so L divided by 2 for this side, and the other side also L divided by 2. And then for the y direction it is unknown, so we just write it y. Okay, for the tangent, because we want to know the theta is how much, so we just write it tangent theta equal to y over x. So in this triangle we can know that tangent theta equal to y is here, y divided by x. Where is our x? X is here, d divided by 2. Okay, d divided by 2. So we just switch the place between each other, so we get y equal to d2 times tangent theta. This one we move upward, so become like this. Okay, then y equal to d divided by 2. Just now we know that tangent theta is referred to 1 over 2 mu s, right? So we just write it 1 over 2 mu s. So we get y equal to d, 2 times 2 become 4, then mu s. Okay, then we using the method Pythagoras theorem to find the distance. To find the distance, we know that the length here L divided by 2 must square equal to y square, here y square plus d over 2 square. So this one we bring it forward, become y square equal to this one we switch behind, so become L divided by 2 then square minus d divided by 2 square. Okay, here we get y square equal to L divided by 2 square minus d over 2 square. Okay, by substitution y equal to d divided by 4 mu s. Okay, substitution inside, so become then this one 2, just write it out 2, then here we just write it L theta, because this one the square we must times to inside to each other, so it become L square divided by 4. So this one also same, just write it minus, and then this one we also need to times inside, so become d square, and then this one 2 times 2 become 4. So this one we get d square divided by 16 mu s square, because this one we get from this also same, this one must times inside, so become d square, and then this one times inside 4 square become 16 mu s then square. Okay, then equal to this one, we just write it as the same situation as the above. Okay, then here we just switch their place between each other. Okay, d square divided by 16 mu s square plus this one we bring it forward, become d square divided by 4. Then this one we just write equal to l square divided by 4. Okay, so after we do this, we must know that the denominator in between these three is different. So to get the same denominator, we just do it like this. Is the normal mathematics solving problem like this one 4 times d, so become 4d square plus 16 mu s square times d square, so become like this, then divide by 4. D square divided by 16 mu s square equal to L square divided by 4 minus D square divided by 4. And then D and D is the same, right? So we bring forward, become plus. So this will become 4D square plus D square 16 mu s square. Then bracket, then divide by 4 times 16 mu s square. 4 times 16 mu s square equal to L square divided by 4. Then the following step is this. D square bracket 4 16 mu s square equal to L square divided by 4 times 64 mu s square. Then D square equal to L square divided by 4 times 64 mu s square bracket divided by 4 plus 16 mu s square. This and this can be cancel it, so become 16. Okay, then the following step is d square equal to 16 l square mu s square divided by 4 plus 16 mu s square. Okay, after this we can know that 16, 4 and 16 we can use the factorization to factorize it out. So become d square equal to 4 bracket 4l square mu s square bracket divided by 4 bracket 1 plus 4 mu s square. And then d square equal to 4l square mu s square divided by 1 plus 4 mu s square. This is because 4 and 4 which can be cancelled it out, so become 1. So we just leave it this 4l square mu s square divided by 1 plus 4 mu s square. Then the following step is, because d is square, right? So we shift the square to behind, so become the square root. So become d equal to square root 4l square mu s square divided by 1 plus 4 mu s square. So the following step is d equal to 2l mu s divided by square root 1 plus 4 mu s square. The 2 we get is because square root 4 equal to 2. Then L2 square root become L. Mu s square become mu s. So thus the answer is 2L mu s divided by square root 1 plus 4 mu s square. This is the final answer for question 2.